This video is brought to you by Altium. This is a getting started tutorial on the ESP32 Wi-Fi plus Bluetooth module developed by the Espressif Systems, the same company that created the ESP8266 series of chips, modules and development boards. Only by looking at the modules, it's hard to tell which one is the ESP32 Wi-Fi plus Bluetooth module and which one is the Nodemcu ESP8266. But if you look closely, you will be able to clearly see the module names. So this one is the ESP32 Wi-Fi plus Bluetooth module and this one is the Nodemcu ESP8266. A monitoring and control system with ESP32 Wi-Fi plus Bluetooth module is very simple as compared to the Nodemcu ESP8266 and Arduino boards. With ESP32, you can control different types of AC and DC loads, and you can also monitor different types of analog and digital sensors over very long range using Wi-Fi or short range using the ESP32 built-in low energy Bluetooth module, and this is the reason I prefer ESP32 over ESP8266, and moreover it has more analog and digital pins. While in Nodemcu ESP8266 we have only one analog pin, A0. So in this video we will only cover the ESP32 Wi-Fi plus Bluetooth module. I will explain the extreme basics which I believe as a beginner you should know. In this video we will cover 1. ESP32 comparison with Nodemcu ESP8266. Number 2. ESP32 Pinout and technical specifications. Number 3. ESP32 board installation using the Arduino IDE. Number 4. ESP32 first LED program. Number 5. BLYNK IoT platform with ESP32 to control a device from anywhere around the world. Number 6. BLYNK IoT platform with ESP32 to monitor a sensor from anywhere around the world. Number 7. Monitoring a sensor using the ESP32 built-in Bluetooth module. And finally, number 8. We will also make a home automation system for controlling home appliances using the ESP32 built-in Bluetooth module. Without any further delay, let's get started. As a beginner, you may find it quite hard to decide whether you need to get started with the Nodemcu ESP8266 or the ESP32 Wi-Fi plus Bluetooth module. Both the modules are developed by the same company, Espressif Systems, and can be used in IoT-based projects. Let's do a side-by-side comparison of both the modules. ESP32 has 32-bit processor with dual core, while the processor in Nodemcu ESP8266 is 32-bit but single core. The operating voltage of both the modules is same, which is 2.5 volts to 3.6 volts. ESP32 has Bluetooth 4.2 plus a Wi-Fi. This is a low energy Bluetooth module and is designed specifically for Bluetooth smart technology, while on the other hand the Nodemcu ESP8266 has the Wi-Fi but no built-in Bluetooth module. So if you need a Bluetooth module, then you will need to externally connect a Bluetooth module. You can start with the HC05 or HC06 Bluetooth modules. These are low-cost modules. Read-only memory is available in ESP32, which is 448 KB, but it's not available in Nodemcu ESP8266 Wi-Fi module. ESP32 Wi-Fi plus Bluetooth module has the EEPROM flash, and this is not available in the Nodemcu ESP8266 Wi-Fi module. Clock speed in ESP32 is 160 MHz clock frequency, while in ESP8266 it's 80 MHz, which is half of the clock frequency used in ESP32 Wi-Fi plus Bluetooth module. Boot flash encryption OTP 1024-bit is available in ESP32 but not in ESP8266 Wi-Fi module. ESP32 has the CAN protocol for automotive communications, but in Nodemcu ESP8266 there is no CAN protocol. In ESP32 Wi-Fi plus Bluetooth module we have more I/O pins than the Nodemcu ESP8266. ESP32 module has more analog pins, while in Nodemcu ESP8266 we have only one analog pin, A0. ESP32 has a 12-bit analog to digital converter, while the ESP8266 has a 10-bit analog to digital converter. ESP32 Wi-Fi plus Bluetooth module is provided with the inbuilt hall sensor and temperature sensor, while in the Nodemcu ESP8266 you will need to externally connect these sensors if in case you need them. ESP32 has 4 SPI, while ESP8266 has 2 of these. ESP32 has Ethernet MAC interface. The ESP32 Wi-Fi plus Bluetooth module is a bit expensive than the Nodemcu ESP8266, but it's really worth it as it has more analog pins, more digital pins, and has a low energy Bluetooth module, etc. This video is sponsored by Altium. Altium Designer is the world's most trusted PCB design system. Altium Designer enables engineers to effortlessly connect with every facet of the electronics design process. Over 35 years of innovation and development focused on a truly unified design environment makes it the most widely used PCB design solution. With Altium Designer, you can create PCB designs with an intuitive and powerful interface that connects you to every aspect of the electronics design process. Route it your way through any angle, tune for delay, push, slide, and walk around faster than ever. Interact and collaborate with mechanical designers like never before in a photorealistic 3D design environment. If you want to get started with the Altium Designer, you can click on the first link in the description. ESP32 Wi-Fi plus Bluetooth module is a 3.3 volt compatible controller board, which means only 3.3 volt supported sensors and boards should be connected with the ESP32 Wi-Fi plus Bluetooth module. If you need to connect a 5 volt sensor with any GPIO pin, then don't forget to use a bidirectional voltage converter module, otherwise this will damage the ESP32 module. Before I'm going to explain the ESP32 pinout and technical specifications, first let's take a look at these two different versions of the ESP32 Wi-Fi plus Bluetooth modules. This one is a 36 pins version of the ESP32 module, while this one is 30 pins version of the ESP32 module. This version of the ESP32 Wi-Fi plus Bluetooth module is slightly bigger, has a connector for the small 3.3 volt LiPo battery. Both modules are provided with these micro USB ports. It really doesn't matter which version of the ESP32 Wi-Fi plus Bluetooth module you have, because both the modules can be programmed using the Arduino IDE. The pin numbers may be different, but their use is exactly the same. You can clearly see this version of the ESP32 module has ESP32 WROM32 printed on it, and the same is printed on this module. In this video, I'm going to use both the modules, but initially I will start with this module to explain the pinout. But for the practical demonstration, I will use this version of the ESP32 module because I have these relays already connected. For now, you don't need to be worried about these components, as I will explain the complete circuit diagram later in this video. This board also has these female headers on the left and right sides, which I can use to connect different sensors and display modules. So basically, We can use this as the development board for testing our code and connections. So let's start with this basic ESP32 Wi-Fi plus Bluetooth module so that you can easily understand the very basic things. This board has these two small LEDs. This one is the power LED, while this LED is connected with the GPIO2. This board is also provided with this 3.3 volt voltage regulator, so you can easily power up this module using a 5 volt regulated power supply. The board is also provided with these two small push buttons. This push button is used for the booting, which is only used when a software update is needed, while this push button is the reset button, which is used to restart the ESP32 Wi-Fi plus Bluetooth module. This module has a total of 30 pins. 15 pins on the left side and 15 pins on the right side. As you can see, all these pins are clearly labeled. It has 2 I2S interfaces, 3 SPI interfaces, 2 I2C interfaces, 3 UART interfaces for connecting serial communication supported devices. It has 18 ADC analog to digital converter channels, 2 digital to analog converters, 16 PWM output channels, and 10 capacitive sensing GPIOs. Out of these 30 pins, the ESP32 WROOM32 has a total of 25 GPIOs, which are divided into 3 groups. Input only pins, the pins with internal pull-up resistors, and the pins without internal pull-up resistors. The input only pins are GPIOs 34, 35, 36 and 39. So if you're planning to use these pins as the input for reading digital signals, then don't forget to add pull-up resistors. The pins with internal pull-up resistors are GPIOs 14, 16, 17, 18, 19, 21, 22 and 23. The pins without internal pull-up resistors are GPIOs 13, 25, 26, 27, 32 and 33. Now let's go through all these pins. Let's start with the VN and ground pins, which are the power supply pins, and this is where we connect our 5 volts and ground wires to power up this module. Remember, apart from the power supply pins and the EN pin, all the other pins are multifunctional, and this is what we are going to discuss now. We have a total of 15 ADC pins available on GPIO pins 13, 12, 14, 27, 26, 25, 33, 32, 35, 34, 39, 36, 15, 2 and 4. With all these analog to digital converter pins, you can connect different types of analog sensors. I will explain this later in this video. The ESP32 Wi-Fi plus Bluetooth module has a total of 10 internal capacitive touch sensors connected with the ESP32 GPIO pins 4, 0, 2, 15, 13, 12, 14, 27, 33 and 32. You can easily convert these pins into capacitive pads, and this way you can easily replace push buttons. You can also use these pins to wake up the ESP32 Wi-Fi plus Bluetooth module from the deep sleep. On GPIOs 25 and 26 we have 8 bits digital to analog converters. DAC 1 is available on GPIO 25 and DAC 2 is available on GPIO 26. All the GPIOs except 34 and 39 can be used as the PWM pins. Using these pins you can control the speed of a DC motor, or you can control the LED brightness, etc. There are a total of 3 serial ports in ESP32 Wi-Fi plus Bluetooth module. The first serial port is used for the programming. The second serial port RX0, TX0 is available on GPIOs 3 and 1. And the third serial port RX2, TX2 is available on GPIOs 16 and 17. In programming, this serial port can be referred to as serial 2. So these serial ports can be used for interfacing serial communication supported devices like GSM modules, GPS modules and other devices which supports serial communication. Unlike the Arduino boards, the ESP32 Wi-Fi plus Bluetooth module also has the I2C bus available on GPIO pins 21 and 22. 21 is the SDA and 22 is the SCL. Using these two pins, you can communicate with multiple I2C supported devices, as every I2C supported device or sensor has a unique address. Later in this video, I will interface an I2C supported OLED display module for displaying the sensor values. All the GPIOs can be configured as interrupts. The EN pin, which is the enable pin which controls the 3.3 volt regulator, by default it's pulled up. So if you want to disable the 3.3 volt regulator, then connect this pin with a ground. So in simple words, you can use some kind of a remote trigger or an external board or a push button to restart the ESP32 Wi-Fi plus Bluetooth module. Finally, you can see the SPI pins labeled as MOSI, MISO, SCK and CS. These pins are used with SPI supported devices like, for example, the famous RFID module MFRC522 uses the SPI communication. Just like the Arduino boards, the ESP32 Wi-Fi plus Bluetooth module can also be programmed using the Arduino IDE. You can download the latest version of the Arduino IDE from the Arduino official website. To download the Arduino IDE, click on the Windows zip file. If you want, you can support the Arduino development team with a small donation, or you can click on the Just Download button. This may take several minutes depending on the speed of your internet connection. Open the Arduino IDE. Go to the Tools menu and then to the board. When you run the Arduino IDE for the first time, you won't see the ESP32 board. You will have to manually install the ESP32 Wi-Fi plus Bluetooth module in order to be able to program it using the Arduino IDE. To install the ESP32 board, you will need this URL link, which I will add in the video description. Click on the File menu and then click on the Preferences and paste the URL link. And also check the compilation and upload boxes, and then finally you can click on the OK button. Again, go to the Tools menu and then to the board, and this time click on the Boards Manager and wait for a few seconds. Search for the ESP32. Select the latest version and then click on the Install button. This may take several minutes depending on the speed of your internet connection. You can see the ESP32 board installation is completed. Now let's go ahead and check if the ESP32 board is really installed. Great, we have just installed our ESP32 Wi-Fi plus Bluetooth module.